This is a SACNAS Science Video Podcast, exploring the lives and research of SACNAS scientists. I'm Cassandra Brooks. Astrophysicists devote their careers to unlocking the mysteries of how stars behave within the universe, tackling questions like, how does a supernova form? What is the gravity inside a black hole? And what happens when two orbiting stars burn up and merge? I caught up with Enrico Ramirez-Ruiz, an astrophysicist at the University of California, Santa Cruz, to find out more about the study of stellar explosions and what it tells us about our place within the universe.
I grew up, having a deep passion for physics, and I really love that astronomy is just a test bed of physics. I'm in fact a fake astronomer in the sense that I don't really look up at the sky. I do a lot of computer simulations, so I'm a theorist. In some ways I try to predict behavior that may be observable in the universe, and I also try to interpret some of the observations that we see.
How do you run a computer simulation?
Yeah, so you basically write a massive code. So the code is basically solving the equations of physics. Yeah, so you have some rules of the game that are basically all put together into a computer. Those rules are very complicated and are non-linear in the sense of how they interact. So it's very difficult to try to sometimes build an intuition just with pen and paper of how those interactions, may give rise to some, wonderful phenomena like an explosive event.
What are you trying to figure out about the universe through running these models?
My sort of area of expertise is what it's called high energy astrophysics. So high energy relates to very energetic phenomena of the universe. For example, I'm extremely interested in a project that it's basically taking a lot of my sleep at night is so neutron stars. So let's talk about what a neutron star is.
Neutron stars, as their name suggests, are comprised mainly of neutrons and are the densest known objects in the universe, according to Enrico. Imagine squeezing the entire mass of the sun into an area smaller than Los Angeles, and you begin to approach the extraordinary density of a neutron star.
So those objects, not only being extreme, they sometimes appear in pairs. So if you have two massive stars that are orbiting around each other, one dies, then the other one dies, they may ultimately leave two of those neutron stars. And we've seen and we have information that a lot of these paired sort of waltzing couples, very massive, dense waltzing couples, live in our universe. And something that I'm very interested in is what happens when they ultimately merge together. So what happens is that they're basically orbiting around, and because they deform space and time, because their gravity is so large, they emit gravitational waves, these ripples that propagate through space and time, and because of that they lose energy, so they come progressively closer, and they rotate faster and faster to each other until they basically become dynamically unstable and merge.
When these incredibly dense stars merge as one, many astronomers believe they emit bursts of gamma rays, the highest energetic photons in the universe. As they waltz faster and faster, getting ever closer and denser, these stars also generate and shoot off precious metals like platinum and gold.
So these objects, become beautiful because they are testing gravitational theory, maybe producing the brightest and more exotic phenomena in the universe, and maybe producing some of the most precious and exotic elements in the universe. So these sort of. So I'm really taken over by trying to understand these waltzing pairs of very dense objects.
Even as astrophysicists continue to decipher the nature of the universe, Enrico reminds me just how vast our universe is, and how lucky we are to live in a solar system that's relatively quiet and free of high-energy explosions that might turn us to gold.
Once you start looking at the diversity of planetary systems as a whole, you realize how unique we are, in the sense that we have an Earth at the right place in which water can possibly exist and so forth. So it does put things in perspective, and at least to me, it does make value more, the planet that we live in and the solar system that we live in.
The same dramatic stellar events that shift and shape the fabric of the universe also provide the building blocks for life on Earth. All of the planet's flora and fauna, including our fellow humans, are comprised mainly of stellar dust, says Enrico.
Most of the elements in the universe were formed in the interiors of stars. So you basically are in some ways understanding the constitution that you're made of and where you came from. You're probably from some god on some star, some far away.
Yeah, I think a lot of people don't think about that. This sort of very deep sense of where we come from.
Yeah, like you can understand it from a molecular level maybe, or from an atomic level, but also understand our composition, which is directly linked to the evolution of the universe. It's sort of mesmerizing that we're here.
With the SACNAS Science Video Podcast, I'm Cassandra Brooks.